Hello everyone, today I want to explain my homework 1 state estimation. This presentation is of my homework 1 assessment on state estimation using the column filter. I will talk to you through the goals, setup, implementation, and result of this project. Here is the outline of my presentation. I will start with the project goal, then move on to the hardware setup, role date, visualization, the crew column filter, implementation, the result, and finally a conclusion. The main goal of this assessment is to demonstrate how we can take a noisy raw signal from a sensor and use the column filter to obtain a clean, intermittent state. This process involved several steps, which I will explain in detail. For this project, I used an Arduino Uno board and a sensor. The sensor was connected to digital pin 9 and 10. The Arduino code shown here is responsible for targeting the sensor and reading the distance measurement, which are then sent to the computer via the several ports. Let's look at this video. This is the measured date. This graph showing the raw date digitally from the ultrasonic sensor. It's clear that the signal is very noisy with a lot of spinches and fluctuation. This raw data is not reliable for precise measurement, which is why we need to apply a filter to clean it up. The column filter works by uncertainty between two steps, prediction and update. In the prediction step, it gets the current state based on the previous one. In the update step, it uses the new sensor measurement to correct that guess. This process effectively reduces noise and gives us a much smoother estimate, as illustrated in the diagram on the left. Here is the Python code for the column filter function. It takes the raw date and the noisy parameters Q and R. The loop goes through each state point, first predicting the next state and then updating it with the actual measurement. This is where the magical happens to filter out the noise. The choice of Q and R parameters is current Q. I set Q to a small value and R to the large value, reflecting that I trust the filter prediction more than the noisy sensor measurement. This code shows how I set these parameters and called the filter function with a raw date. This is the most important slider. The green line is the row noisy date, and the red line is the result after applying the column filter. You can see a dramatic improvement. The red line is much smoother. Effectively removing the noise while still actually following the actual movement of the object being measured. In conclusion, I have successfully implemented the column filter to isolate the state from noisy sensor data. The result clearly shows that the filter is effective in removing noise while providing a smooth instrument. This assignment has helped me understand the practical application and the turning of the column filter. Let's look at this video. This is our measure date. This is HomeworkNo.1 function code. This is all my homework 1. Thanks for listening. See you.